Hello, my learners. I'm glad you can join me today on another chemistry session. Today in chemistry, we'll be concluding our discussion on bases. Earlier, we have discussed bases, we have defined bases, we have stated the property of bases, and also we have looked at both physical and chemical properties of base. Today, we'll be going further to look at chemistry under the basis under the following top topic. We'll be looking at method of preparation of bases. We'll be looking at uses of bases. We'll be talking about the concept of pH and pOH. And of course, we'll conclude by looking at what we call the pH scale. Now, let me start by talking about the method of preparation of bases. Now, bases can be prepared by burning of metal in air or oxygen. When you burn metal in air, you get metal oxides. And these metal oxides are also called basic oxides. So, example, when you burn sodium in oxygen, you will get sodium oxide. Or when you burn calcium in oxygen, you will get calcium oxide. So this is one method of preparation of bases. So to the action of water on some metals. Now, very electropositive metal react with water to form a base. Example of such electropositive metals include potassium, sodium. As you can see, sodium plus water will give you sodium hydroxide and liberating hydrogen gas. Now, we can also do that by dissolving oxides in water, by dissolving oxides in water. For instance, when you dissolve calcium oxide in water, you get calcium hydroxide. Bases can also be prepared by decomposition. Decomposition means heating. When you heat trioxocarbonate 4 of some metals, you produce a base. For instance, calcium trioxocarbonate 4 will give you calcium oxide plus carbon 4 oxide. Calcium oxide is, of course, a base in this case. So now let's look at action of alkali on salt solution. For instance, if we have magnesium tetrasulfate 6 and we react it with sodium hydroxide, we get magnesium hydroxide plus sodium tetraoxosulfate 6. Now, these are ways that you can prepare base, even though there are so many other methods you can use to prepare bases. So let's look at the uses of bases. What are bases actually used for? In chemistry, sodium hydroxide, potassium hydroxide is used in the manufacturing of soap. We have hard soap and soft soap depending on the base that you use. If you use sodium hydroxide, you get a hard soap. When you use potassium hydroxide, you get a soft soap. We'll talk about soft soap formation or saponification reaction in our future discussion in chemistry. My wonderful student, calcium hydroxide is used in the manufacturing of bleach. Yes, it's used in the manufacturing of bleach. Calcium oxide and calcium trioxocarbonate 4 are used in correcting pH in soil and water. When a soil or water solution is too acidic, when you add calcium hydroxide, you will call it liming, either post-liming or pre-liming, as the case may be in treatment of water. Now, bases are also used in the preparation of ammonia gas. In the just concluded lesson, we saw how bases can react with ammonium salt to liberate ammonia gas. Now, these are some of the uses of bases. Now, let's look at what the concept of pH is. Yes, what is pH and what is pOH? We'll be looking at the concept of pH and pOH, and we'll be taking a couple of examples from that concept, and that will help us to understand the concept more and as we round up our lesson today. So what is pH? Now, if you look at other subjects like biology or agriculture, they will say pH is the acidity or alkalinity of a solution or of soil or anything. But in chemistry, we see pH as a negative log to base 10 of hydrogen ion concentration. Again, is the negative log to base 10 of hydrogen ion concentration. As you can see, pOH is also the negative log to base 10 of hydroxyl ion concentration, or the negative log to base 10 of OH minus concentration. Remember that your pH plus your pOH is equals to 14. We can see that more when you look at what we call the pH scale. Now, what is pH scale? Now, pH scale is the scale that shows the degree of acidity and alkalinity of a solution. You can see the pH ranging from 1, 2, 3, 4 up to 14. Now, when you start your pH from 1 to 7, we said from 1 to 6.9 is acidic. And as you are moving away from 1 and moving towards 7, the acidity is decreasing, so that we can say a pH of 1 is more acidic than a pH of 2, a pH of 2 is more acidic than a pH of 3, and a pH of 6 is the least acidic before you get to neutrality. So at 7, a sample solution is said to be neutral. Now, as we move away from neutrality, from 8 to 14, we say it's alkaline, meaning that 8 is more alkaline than 9. 9 is more alkaline than 10. So as we tend to move away from neutrality, the strength of alkalinity increases. So 14 is the most alkaline and 1 is the most acidic. My student, let's take a couple of examples to see how you can attempt questions on pH when the need arises. For instance, calculate the pH of 0.2 mole per dm cube hydrochloric acid, HCl. Now, you first of all ionize HCl to give you hydrogen plus Cl minus. Note that there is only one hydrogen ion there, so the pH is equals to negative log to base 10 of hydrogen ion concentration. And our hydrogen ion concentration is 0.2 moles per dm cube. So if you say pH is equals to negative log to base 10 of 0.2, you have pH to be minus, open bracket, minus 0.69897. Now, if you multiply minus by minus and open the bracket, you have pH to be equals to 0.699 to 3 significant figures. I'm sure you will have seen this example, and you can solve other numerous examples that relate to this. Now let's look at another example. Calculate the pH of 0.05 mole per dm cube tetrasulfate 6 acid. If tetraoxosulfate 6 acid ionizes, you will find out that it has two hydrogen ions, so that the concentration is no longer 0.05, it's going to be 0.05 times 2, which will give you 0.1, because the hydrogen ion concentration is 2. So we say pH is equals to negative log to base 10 of 0.1, and 0. Log of 0.1 is minus 1, so that minus multiplied by minus 1 will give you 1. So our pH for this is 1. My wonderful student, how can you apply this in calculation of pOH? Yes, let's look at the next example, as it will be talking about the pOH. Now look at it. It says that calculate the pH of 0.001 sodium hydroxide. Now sodium hydroxide is a base. Ordinarily it have a pOH. So we first of all look for the pOH of 0.001 sodium hydroxide, so that we say pOH is negative log to base 10 of OH ion concentration, such that the concentration of OH minus is 0.0001, so that we say pOH is equals to minus 10 log 10 0 of 0.001, and that will give you pOH to be equals to minus, open bracket, minus 4, such that pOH is equals to 4. Now remember, we are asked to calculate pH, and there's a relationship between pH and pOH, and the relationship says pH plus pOH is equals to 14. So that if you substitute your pOH to be 4, then you have your 14, which is pH is equals to 14 minus 4, which will give you 10. The pH of that solution will be equals to 10. I've come to the end of this lesson today, but I wouldn't allow you to go without having something to test whether learning has taken place or not. So get your pen and paper and try this assignment. And I'm sure you can reach me on my phone number 08026598861 on WhatsApp. And let's see how you have actually learned. Now, the first question says define a base. Number 1B says state the type of bases with one example each. Number 2A say list 3 physical and chemical properties of bases. Number 2B say with a suitable equation, write 3 methods of preparation of a base. And number 3 says all alkali are bases, but not all bases are alkali. Discuss. Lastly, we said a sample of a gastric juice has a pH of 2.5. What is the hydrogen ion concentration in the secretion? Remember, your pH is equals to the negative log to base 10 of hydrogen ion concentration. If you made hydrogen ion concentration to substitute of formula, I'm sure the antilog will lead you to the answer. Have a beautiful day. My name is Mr. Philip Maman. Keep learning, and I'm hoping to see you more on my YouTube channel. Have a blessed day.